Hi and Assalamualaikum. In this video, our team will present about our ITT633 group project. Our project is DHCP with net overload or PAT pad automation using Python. So before we begin with presentation, I would like to introduce about our team members, which consists of me, the leader, Meor Hafizuddeen bin Muhammad ZAMRI, and my team member consists of DAYANG SHAZLEEN FITRI binti AWANG SHARIEE, HAZWAN NAJMI bin HUSAINI, and MUHAMAD HAKIMI bin HASHIM.
Introduction. Network Automation for Dynamic Host Configuration Protocol or DHCP with NOT overload, also known as Port Address Translation or PAT, can be done using Python scripting to automate the DHCP management and configuration of NOT, which ensure the efficient IP address allocation and translation for multiple devices within multiple networks. This automation improves scalability, reduce the needs of manual network device setup, and ensure standardized configuration processes. This leads to an automated and efficient network administration environment and infrastructure. Moving on to the next one, which is problem statement. The manual configuration and management of DHCP and NOT or PAT pose challenges in network administration, leading to potential human errors and risk of configuration mistakes. This manual process is also called time-consuming, especially in large network, leading to scalability issue and efficiencies of managing the whole network infrastructure. The next one is objective. Develop a Python script that automates the management of the DHCP alongside the configuration of NOT in a network. The second one is ensure the efficient IP address allocation for multiple networks through DHCP services automatically configured on multi-layer switches. The third one is IP translation of private addresses to public addresses via NOT or PAT for multiple devices in multiple networks configured on routers. And the last one is automation of Python script will enable the network administrator to telnet all multi-layer switches and router in the network topology and automate the DHCP and NOT configuration on respective network devices from a remote host.
Project scope. Python script automated DHCP and NOT for multi-layer switches and router in this project. It managed dynamic IP assignment on multi-layer switches and NOT translation with dual public IP assigned to the routers. Basic security tasks like telnet credential, static IP assignment, and static routering for router are done manually to ensure accurate routing and IP translation. Here is our network topology. We are using 2 routers and 4 multi-layer switches, and here is for our HQ router, and here is our branch router. So for each block we are using multi-layer switches, and for each block we are having 2 departments, and we are applying net overload for each router for using to translate private network to public network. Here is our private IP network, and by using net overload we can translate to outside network, which is the public network. We get this IP public. So for each block we are applying DHCP at the multi-layer switches to configure IP address dynamically, and for network admin can access for each department, for each network area by using remote host. For our software requirement, we are using GNS3, VMware Workstation, and Notepad.
There are 4 methods for this project. The first method is software installation. There are two tools to be used in this project, which are JNS3 and VMware. These tools are downloaded and installed on your laptop to be used to stimulate this project. Notepad also is already pre-installed and will be used to write Python script. The second method is deploying network topology on JNS3. In this method, there are several necessary appliances for the network topology, which consists of Cisco router 7200, Cisco multi-layer switch 3640, and Ubuntu Docker Guest. These appliances are downloaded and imported from JNS3 Marketplace, as they are not pre-installed by default. Next, the design topology is deployed in JNS3 by adding routers, switches, and computer or PC to the workplace. The routers and the switches are pre-configured with basic security, default routing, and static IP assignment, as it is needed to make sure the DHCP and NAT automation works, but not in the scope of this automation project. The third method is Python script development. Python scripts are developed and written in Notepad to automate DHCP services and NAT overload or pad configurations. The scripts will then be copied as a Python file using the command nano netautomation.py in the remote host terminal in JNS3, which acts as the network administrator that manages the network. The last method is testing and validation. The DHCP and NAT will be automated with Python by executing the command python netautomation.py on the remote server. DHCP address assignments of private addresses to hosts will be verified according to the expected network address pool. NAT overload functionality and connectivity will be validated using ping and show NAT translation command in network devices CLI.
Okay, next I will explain about the result and analysis by doing demonstration in JNS3. First, this is the network topology that is deployed in the JNS3, and we'll start with looking at the current configuration of the network devices. We start with router configuration. Show run. It shows that we have manually configured telnet information, which the username is NAJMI and password Cisco. And we also configured interfaces with IP addresses and the static routing in the router, because routing we do not do automation, because this project only cover for DHCP and NAT configuration. So we use static routing by configuring manually, because this is routing is needed to verify and testing the NAT and DHCP configuration works as expected. So the configuration the same on the multi-layer switch, which the telnet information NAJMI and password Cisco, and also the interfaces is configured with IP addresses. And then we also check for the NAT configuration on the router by using the command show IP NAT statistic. So there is no output display because the router is not yet being configured with NAT configuration. The same for branch router. No output display showing that there is no NAT configuration being done. On the multi-layer switch, we use the command show IP DHCP pool. No command is displayed because all of the multi-layer switch is not yet being configured with DHCP configuration. The same for block B multi-layer switch, block C multi-layer switch, and block D multi-layer switch. Okay, now output display is showing that all of the network devices is not yet being configured with any NAT configuration or DHCP configuration. So to do the configuration, we use Python script, which the Python file is located in the remote host of network admin connected to HQ router. So this is the terminal of the network admin. It contains the net automation.python, which is the Python file that will be used for doing the automation of DHCP and net configuration. So to view the Python script or edit the Python file, we use the command no, and this shows the Python script that we have written for the Python file. And then we check for the IP address of the remote host, which is 172.165.1.2. This is the IP address of the remote host network admin. So we straight away run the Python file to do the automation and make configuration of DHCP and net. We use the command python net automation.py. So it already ran the Python file. First, it will greet the user and will ask for the telnet username, which is net admin in this case, and password Cisco. So we entered the password and username. So the Python file will automatically telnet into each of the network devices and do the configuration. For example, the configuration for block A multi-layer switch with DHCP configuration, block B multi-layer switch with DHCP configuration, C multi-layer switch, and D multi-layer switch with also DHCP configuration. Then we'll do the HQ router configuration with net configuration, and branch router with also net configuration. So to check this, we will see all of the network device will be notified with telnet information, which is the net admin access on BTY0. The same goes to all of the network devices. So the Python file output shows all of the configuration done in just one terminal. So network admin just review all of the configuration in just one terminal. So to check for the configuration on all of the devices, we use the same command, which is show IP net statistic on the router. It shows that there is output. So net configuration already done on the router, which is HQ router serial 20 is outside interface, and fast internet 10 and fast internet 11 is the inside interface. So this is the outside interface and this is the inside interface. And also access list for permitting network from department 1 until department 4. And then same goes to branch router. So it also configured with net configuration. So for DHCP configuration, we go to the multi-layer switch. So block A is configured with DHCP pool of LAN 1 and LAN 2, which is department 1 and department 2. So it shows that before there is no output or no DHCP configuration. So after we run the Python file, it is the block A multi-layer switch configured with DHCP configuration. Same goes to block B multi-layer switch for LAN 3 and LAN 4 for department 3 and 4. And block C multi-layer switch with LAN 5 and LAN 6 for department 5 and department 6. And lastly, block D for department 7 and department 8. So this shows that all of the network devices is configured with NAT configuration and DHCP configuration. So next, to test this this DHCP and NAT configuration works as expected, we choose PC1 to check for the DHCP services. So we enable DHCP services by doing the command IPDHCP. So PC1 will request for IP address using DHCP from block A multi-layer switch. As multi-layer switch block A is for department 1, the network is 192.168.1. So PC1 is assigned of IP address .16 using DHCP from block A. So this is the correct IP assignment. So showing that DHCP works as expected. So we test another PC. So PC8 will request for department A from block D multi-layer switch. So department A is .8.16. So this is the IP address of PC8. So this shows that DHCP works as expected. And then for the net configuration, to test and verify, we ping from PC1 to any of the device in the branch segment. This is the HQ segment which contain PC1. So to PC1 using private address. So to access and communicate devices in the branch segment, it needs for IP translation, which is done by HQ through net overload translation. So we ping, for example, block D. Block D SVI or VLAN 1 172.16.4. .1. So the ping is success, showing that PC1 can communicate with block D multi-layer switch, which is in the another segment of branch segment. So the ping is success, which is 5 packets of ICMP packets. So to verify the net translation, we go to the HQ router, because it's the router that done the translation, using the command show IP net translation. So because PC1 sends 5 ICMP packets, so the translation is also 5 net translation. So it translates from 192.168.1.16, which is the IP address of PC1, to 172.16.4.1, which is the SVI or IP address of block D multi-layer switch. So it translates from local to global or private to public, which is 209.165.200.1. This is the public address, and it using the same IP address for all of the translation, but the port address is different because we use net overload or PAT port address translation. So this shows that net configuration also works as expected. So from this shows that Python script is successfully configured all of the network devices with net configuration and DHCP configuration for router and multi-layer switch, and work as expected. So the aim of objective of this project is achieved.
So the conclusion for this project is the Python script is employed to streamline the setup of multiple devices by running a single file on a remote host. This can eliminate manual configurations and reducing the risk of error. These efficient approaches save time and enhance scalability while maintaining easy updates through script modification. Besides that, automating DHCP and NAT or PAT can also enhance dynamic IP allocation and communication between devices in various networks. Using a Python script ensures accurate configuration, preventing errors in DHCP pools and NAT interfaces. This automation is crucial for efficient and error-free network administration. Thank you.